Because the eyes move together, the other eye, it means, is the medial rectus, which is in moving the eyeball towards the same direction. Eyes must move into the same direction together. If you have one eye looking up, another one down, there is a problem there. So these muscles work in pairs from the two eyeballs. So basically, 3 nerves are involved in innervating the muscles that move the eyeballs. We've got the 3rd cranial nerve, the 4th cranial nerve, and the 6th cranial nerve.
This meeting will end in this meeting will end in 10 minutes time. We have to pay for it.
You want to start again? Or you want some more to expand it?
I don't know, I was checking. Someone was saying that the volume was not.
Oh, volume was not okay. Okay. Let's look at the oculomotor, or the 3rd cranial nerve. The nucleus for this nerve is located at the level of the superior colliculus beneath the aqueduct or the aqueductal gray matter. So it's within the midbrain. Nuclear complex has subnuclei with crossed and uncrossed combined projections to individual extraocular muscles. What does that mean? Okay, so it's a 3rd nucleus, but there are also smaller ones which make up the whole lot of 3rd nucleus. So you've got what we're calling the subnuclei. Okay. Inferior oblique muscle, inferior rectus, and medial rectus subnuclei have uncrossed projections. Maybe if I can explain to you exactly from at this point. When we say crossed projection, it means the nucleus is on the right, is on the right side. The fibers from that nucleus are innervating a muscle on the left side. That's cross effect. But if you have got a nucleus or a subnucleus which are on the right side and going to innervate muscles on the right side, those are uncrossed. So when you hear crossed and uncrossed, that's the concept which is there. There are certain fibers which have to cross over to innervate the muscles from the other side of the body. So what we're saying here is the inferior oblique, the inferior rectus, and the medial rectus subnucleus have uncrossed projections. It means inferior obliques, these subnucleus on the right side will supply the right side. On the left side, they will supply the left side. Okay. Then levator muscles share projections from a single midline. Levator muscle is responsible for elevating the eyeballs to look up. The fibers which innervate the levator muscles in both eyes come from a single central nucleus at the back. I think this is very important for you to appreciate when there is a when there is a palsy, failure to move of the movement of the eyeball. For you to be very sure what you're talking about, you have to know where the fibers are located, where the nucleus for those fibers are coming from. Please, this aspect must be clearly understood. The nucleus located at the level of the superior colliculus beneath the aqueduct. Nuclear complex has a subnuclei with crossed and uncrossed fibers and combined projections to individual extraocular muscles. So inferior oblique, inferior rectus, and medial rectus subnuclei have uncrossed projections. In other words, these subnuclei on the left side, the fibers from there go to innervate muscles that are on the left side. That's the meaning of uncrossed. While the levator muscles share projections from a single midline central to the subnucleus. Some other nucleus will cross over to go and innervate muscles on the other side. Please, as you study, you must understand this situation. Because if you don't understand, because it's the left muscle which is weak, you will think, okay, it's the left nucleus, it's the left nerve, but a question might come, where is the nucleus for these fibers? You should be able to tell us where the nucleus is. If we continue with the nucleus, the superior rectus subnucleus has crossed projections. Right superior rectus subnucleus innervates the left superior rectus. That's the crossed projection we're talking. And vice versa, left innervates the right one. That's the meaning of who crossed. Then you've got the Edinga Westphal subnucleus, which gives out the parasympathetic input to the ipsilateral pupil sphincter pupillae. The sphincter pupillae constricts the pupil. The fibers which go to the sphincter pupillae are coming from the Edinga Westphal subnucleus, and the left side goes to the left eyeball. The right side goes to the right side. So in nuclear lesions, ptosis should be bilateral or absent. Superior rectus is involved contralaterally and spared unilaterally. I hope people understand the meaning. In other words, superior rectus pause is involved contralaterally, meaning the fibers are coming from the opposite side of the left superior rectus, fibers are coming from the right. The right superior rectus, fibers are coming from the left. That's the meaning of superior rectus is involved contralaterally and spared ipsilaterally. Because the fibers are crossing over to the left fibers from the left side are supplying the superior rectus on the left side, it means the superior rectus on the right side, where the actual fibers are coming from, is spared. Because these fibers are supplying contralaterally. When we talk of fasciculars, in neurology, you've got the nucleus, then you've got these fibers. Before they come out, there's a bundle within the brainstem, which is moving. That's what they are referring to as a fasciculars. Oculomotor neurons leave the nuclear complex and pass ventrally. First, oculomotor, what is the function of oculomotor? Oculomotor is basically involved in the movement of muscles of the eye. Okay? So oculomotor neurons from the nucleus, they come out, leave the nuclear complex and pass ventrally through the red nucleus, leaving the brain stem through the medial portion of each cerebral peduncle. I hope I've got a diagram down there. Fascicular lesions can lead to isolated, complete third nerve pauses with pupil involvement or with pupil sparing. Vascular and metastatic lesions may be the cause. When we say vascular, it means there's a break in the blood vessels and that blood damages the fibers there. Or tumors, you can have that. When the lesion involves the red nucleus, Benedict's syndrome, there is ipsilateral third nerve palsy. Contralateral loss of sensation and tremors in the arm and leg. Lesions involving cerebral peduncle and third nerve fascicles produce Weber's syndrome. And spastic paralysis of contralateral arm and leg, ipsilateral third nerve palsy. This will go over and over and over until you are all clear. So suppose when you have a patient, when you see at the patient, when you examine the movements, you should have an idea where the level of the lesion is. That's the whole idea of studying this. Firstly, to determine, is it the right nerve or is the left nerve involved? At what level?